Alright, so when we are factoring the perfect square trinomials, we're going to factor it into the square of a binomial. It is very simple. If I have this situation where b divided by 2 squared equals a times c, that's telling me that this particular problem, trinomial, is a perfect square, which means that it can be written as the square of a binomial. What is a perfect square? Alright, think about 25. 25 is equal to 5 squared, right? So 25 would be a perfect square. So it can be written as something squared. Well, this trinomial can be written as something squared. The something is going to be an expression. For this problem, it's going to be x plus 4. Now, where do you think the 4 came from? 16. Square root of 16 is 4. All right? It's also half of 8. Half of 8 is 4. All right? So this one's going to be not x plus 9, x minus 9. Okay? Yep, the sign comes from the middle. All right? The next one will be what? X plus what?
X plus 1.
1. And this last one will be what?
X minus 5.
Yep. So there's two ways to determine, to think about what goes into what number we're using with the x. Probably the best way is just to take half of this middle term. That way you'll never get your sign wrong. If you just take the square root of the last term, it's always going to be positive. So you might put a positive when it's supposed to be a negative. So look at the middle term and take half of it to get what number goes in parentheses. Now, you can only do this like this fast, when it is a perfect square trinomial. But the reason we're talking about this is because we're about to create perfect square trinomials, which shows that we can do this, allows us to do this every time, because we are actually creating the perfect square. That's what this process is all about. Standard form converted to vertex form requires us to complete the square. That is, to make a perfect square trinomial. So let's read through this. It says, if the standard form equation is a perfect square like example 1, any of these up here, simply factor to convert to vertex form. If it's not a perfect square trinomial, you can use a process called completing the square to write the equation in vertex form. Now I'm going to go ahead and tell you, I don't generally check first to see if it's a perfect square trinomial. I just do the process. And if I know what I'm doing, it comes out right every time. So you don't have to check to see if it's a perfect square trinomial to start with. Alright, let's go through the steps. The first step is to just look at the ax squared plus bx part. Well, if we look at example 1 right here, number 1, that's just this part right here. That's what I want to focus on. Okay, I'll explain that in a minute. So, the next step is if a is not equal to 1. In other words, if I had a number out front, and this a value right here, in our vertex form, or even this a value here actually, if this a is not equal to 1, I would have to factor it out. And I'll show you how to do that in just a minute. It would look something like this. It would be ax squared plus b over a, this should be over a, times x. Alright, number 3, complete the square by taking half of b and squaring it. This is the new c. Add this to x squared plus bx. This is the perfect square trinomial. I'll explain that in a minute. Next, you have to subtract ac from the end of the equation. That doesn't make any sense to us right now. I'll explain it. Number 5, factor the trinomial, that is, factor the perfect square trinomial, and simplify the end of the equation. None of this really makes sense. But after we do a few of these, it's going to make perfect sense, because it's really easy. For some reason, my students do really well with completing the square. Alright, so here we go. The first step is to isolate or focus on the x squared plus 4x part. What I mean by that is, I'm going to rewrite it with x squared plus 4x inside parentheses, but then after the 4x, I'm going to leave a little space. I like to put a little blank there, Because, you know, if you're doing a test or something, if there's a blank, the assumption is that you're going to put something in the blank, right? There's something that goes in that blank. Well, something goes in this blank. So we're going to put a little blank, close our parentheses, and then write the last term, which is the 4, outside parentheses. You can see this starting to look like vertex form, which is something in parentheses squared plus or minus a number. All right, now, the next step is to complete the square. Now, completing the square simply means we're going to take half of this x term. What's half of 4? 2. So we're going to take 2. We're going to square that. And what is 2 squared?
4.
It is 4. So the 4 gets added in the blank. That's what goes in the blank. And just so you know, you will always be adding in that blank. Because if you square a negative or a positive, it's always positive. So you always be adding in this blank. Now, I want you to think about equations for a minute. The number one rule of equations is that you have to do the same thing on both sides of the equation, right? You can't add a number on the left and then add a different number on the right. Or you can't subtract on one side, add on the other, and stay balanced. So, in order to stay balanced, those values on the left and right have to be the same, that you add or subtract or multiply or divide or whatever. Well, we're only working on one side of this function. The left side says f of x. We don't do anything over there. We only do it on the right. So, in order for me to stay balanced, if I added a 4 right here, what am I going to have to do out here?
Add a 4.
Well, that wouldn't be balanced, right? Subtract the 4. Because if it's going to stay balanced and stay the same as it was before, I've got to change, I'm changing the way it looks, but I can't change the value. If I add 4 again, now I've not only added 4 here, I've added 4 out here, so I've added 8, but I didn't balance that with anything. So to balance adding 4 here, I have to subtract 4 out here. That's what we do. Okay, and you'll see there are some exceptions in terms of sometimes we have to add out here instead of subtract. And I'll show you that in a minute. Alright, so with that done, now we can factor this into the square of a binomial like we did up here. So what's going to go in parentheses?
Why you put minus 1?
That's what I was talking about. If we add 4 on the inside, we have to do the opposite to the outside to stay balanced. X plus 2 squared. Alright, because what is half of 4? 2. Alright, now on the outside, what happens to the 4 minus 4? It's just 0. Okay, now do I really need the 0 there? No. So my final answer is just x plus 2 squared. Okay, this is vertex form. Now, it does ask us to write the vertex. So what is our vertex? Negative 2, 0. Okay? Alright, so we did it. We converted from standard form into vertex form. Now we're going to do more of these, and you'll see as we do these, the process will start to become very easy. Alright. Okay, the next problem. We've got just x squared minus 8x here. We want to put that part in parentheses. So here we go. X squared minus 8x. Leave a blank. Close your parentheses. And then write plus 18. So it's like I'm just adding this little part that wasn't there to begin with. So what? Technically, you probably should put a blank after the 18 also. Because I'm going to do two things that are going to balance each other out, right? Well, what's half of negative 8? Negative 4. And what's negative 4 times negative 4? 16. So I'm going to add 16 right here. And minus 16 out here. Because I've got to stay balanced. And you say, wait a second, that's not... If you're just adding 0, you're not changing anything. You're exactly right. I'm not changing the values of anything. I'm just changing the way it looks. I'm not changing values or what things mean. I'm just changing the way it looks. You know, if you get a haircut, you're not changing you're just changing the way you look. Okay? So that's all we're doing here. We're just getting a haircut. Alright. Now, we've got to take this parentheses part. This is our perfect square trinomial now. We completed the square to make this a perfect square trinomial. You say, you completed the square? What do you mean, Coach? You completed the square. Alright, look at this. There's a part missing to that square. You say, that's not a square. Yes, it is. It is. It's a square. There's a part missing from that. So I had to figure out what that missing part was. That's basically what I'm doing. This can be a perfect square trinomial, but I've got to know what the missing part is. So in this problem, it would have been, this missing part right here would have been a 4. So I would have had an x, or technically a negative 4, a negative 4, and this side is x minus 4. So x minus 4 times x minus 4 is this. Alright, so let's write this as x minus 4 squared, and then 18 minus 16 is 2. Now what is our vertex? 4, 2. Okay? Alright, let's keep going. Now look at number 3. Number 3 is a little different. Can somebody tell me what's different about number 3? Exactly. So what that means is we have got to factor out that negative. We can't complete the square with a negative in there in front of x. So we're going to factor it out. The word factor means basically to divide. If I'm factoring out, I'm dividing it out. So I'm going to have the negative in front of the parentheses. If you want to make it negative 1, you can. That's fine. You can say negative 1. Alright? Now, what I just did is I divided that negative 1 out. So what is negative 1 divided by negative 1? Positive 1. That leaves an x squared, right? And then I'm only doing this to the x terms. So what is 6 divided by negative 1? Negative 6. So all I did was change the sign. Now leave a blank, make a blank, a little space, close your parentheses, and then minus 5 and a blank. Alright, so we got to figure out how to complete this square. So we want to take half of negative 6.
Negative 3.
Negative 3 squared is?
9.
Positive 9. Remember, you always add on the inside of the parentheses.
So you wouldn't change to negative 5?
Hold on. No, negative 5 stays. We're going to add something or subtract something to it.
Yeah, it'd be 9.
Alright, so here we go. Here's where you have to be careful. Is this really a 9, a positive 9?
No,
It's a negative 9. This negative 1 is still there. So if I did negative 1 times 9, I get negative 9, right? So instead of subtracting 9 out here, I'm going to have to add 9. I have to do the opposite of whatever that number really is. Bobby, you getting this? Jalen, last year, you getting this? Bobby, you getting this?
But you adding that right now.
Because I promise you, you're not going to know how to do it if you don't pay attention. Alright, that's the thing. This is plus 9. It's always going to be plus on the inside of the parentheses. But it's not really plus because there's a negative right here.
Oh.
Negative 1 times 9. Exactly. Glad you said that. It's distributed to all of them. So that's what it really is. Alright, so instead of subtracting like we did up here, now we're adding only because there was a negative out here, which changed my sign, which caused me to have to do the opposite. Alright, so we can now bring down the negative 1, do your parentheses squared, and here's a common mistake, guys. A lot of students want to put an x squared inside the parentheses. It's just x. X minus 3. And then negative 5 plus 9, positive 4. And then we can do our vertex. So what is our vertex?
3, 4.
Yep. Very good.
Hey, I'm actually learning.
Good. I don't know what it is But in my experience, over all the years I've been teaching this stuff for many years, my students do great on completing the square. I don't know what it is. It's not the easiest thing to do, but students do great on it. So y'all will too. Alright, here we go. This next one. Notice there's not a negative in front of x squared, but there is a 2. We're going to put the 2 on the outside of the parentheses. Now, on the inside, you got to divide out the 2. So, 2 divided by 2 is 1. That leaves x squared. And then negative 12 divided by 2 is negative 6. Don't forget your x. Leave your blank. Close your parentheses. Plus 13 blank. Alright. Now, we got to complete the square. It's actually going to be the same as it was before, right? Because half of negative 6 is negative 3. Negative 3 squared is positive 9, so add 9. But be careful on the outside. Because is this really a positive 9?
No.
What is it?
It's a negative 9.
Well, no, I said that wrong. Is it really a 9?
No.
It's an 18. 2 times 9 is 18. So what goes out here?
Minus 18.
Minus 18. You have to do the opposite of what this really is. And that's where you have to be careful, and that's where students make mistakes. On the quiz today, a lot of students made the mistake of not remembering that this was something, they just went on what was on the inside instead of what was on the outside with the inside. Alright, so now, bring down your 2, parentheses squared, again, it's the same as it was before in the previous problem, x minus 3 squared, and then minus 5. No, 13 minus 18 is negative 5. 3 negative 5. Okay? Yes. Alright, so is this a 9? Yes, but is it really a 9? It's really an 18. Because this 2 is technically being distributed onto each of these. Because it's got to be the opposite. So 2 times 9 is 18, so the opposite of that's negative 18. Because you've got to maintain that balance. You're technically adding 0, which it doesn't change the value of anything, but doing it this way changes the way it looks. Alright, so let's go to the back side. There could be decimals, yes. Number 5 is a decimal. But you do it exactly the same way. You're just going to have decimals. You could leave it as a fraction. Either way is fine. Alright, let's look at number 5. Now, the only thing different about number 5 compared to the very first example that we did is that there's an odd number for the b value. All that means is we're going to have a decimal. It's fine. It's okay. Your calculator can square decimals. No big deal. Alright, so here we go. So you're going to have x squared minus 3x, leave some space, parentheses, minus 2. Now, I didn't have to factor anything out, did I? Alright, so what's half of 3? 1.5. 1.5 squared. Somebody put 1.5 squared in the calculator. 1.5 times 1.5. 2.25, which is 2 1/4. So I'm going to leave it as a decimal. So, yes, thank you. Alright. Now, there was nothing out here, right? Right. There's nothing out here. So, because there's nothing out here, we're going to do the opposite out here. So, minus 2.25. Somebody was asking me a question. Who was? There we go. Now we're good. Huh? Yes. No. It's always going to be positive right here. Because if you square a negative, you get a positive. So half of this is negative for sure, but if you square a negative, it becomes positive. Will you nudge Ethan, please? Hey, Afferson's got you, man. He's got you. I'm expecting him to maybe do better than you on the quiz tomorrow.
They put Afferson back on his list.
Okay. Yeah, he will. He's going to. He's paying attention. That's all. I mean, that's all it takes. Huh? If you don't know when you're asleep versus when you're awake, then there are some issues. Well, you probably were listening, but you're not seeing. Alright, I like that hat, though. Yeah, because I know the guy that owns that. Alright, South Central.
Hey, you don't have medicine now, that's why.
Alright, so, here we go. So, we're going to write this as what?
X minus 1
Well, x minus 1.5.
I just put 1
That's fine. X minus 1.5 squared
minus 4.25.
minus 4.25. Alright, now, look, you can write these as fractions. Your calculator will convert it to a fraction for you. If you go to alpha y equals, actually, I'm sorry, before that, you need to do, plug in 1.5. And then, go to alpha y equals. Go down to number 4 and press enter. And then press enter again, and it will convert the decimal to a fraction. 3/2. So this could be written as x minus 3/2 squared minus, this is 9/4. Either way is correct. The vertex is going to be positive 1.5, comma, negative 4.25.
See, 1.5. See, I don't like that. I don't like all the negatives and all that.
Alright, do number 6. It's going to have a decimal. And you got to factor out a negative. Try to do it on your own. It's very much like this one.
You said it was 6.
It's still what?
It's still recording.
Oh, okay, good. I'll stop that. Thank you.